The second part of our lesson was looking at equivalent fractions and reducing a fraction to lowest term. So if we look at equivalent fraction first, all this is we're creating another fraction that has the same value, but just using different numbers. So for example, let's take our fraction of 3/4. So here we've got 3 out of 4 pieces. Now, if we took this circle and we cut each of these slices in half, so let's create the same one over here. And let's highlight 3 out of 4. But before we write our fraction, we're actually going to cut each of these slices into 2 pieces. Okay, so now we have 2, 4, 6, 8 slices in our whole, and we have 2, 4, 6 out of the 8 pieces that are shaded. And these two fractions are what we call equivalent fractions. So 3/4 is equal to 6/8. Now, how do we get an equivalent fraction? Well, in our lesson, the students are asked to take any fraction, let's say, for example, 2/5, and to create an equivalent fraction. And they can do this using any number they want to, but the requirement is they have to multiply the top and the bottom by the same number. So let's take, for example, 3. So we're going to multiply it by 3 and multiply by 3. And our fraction will be 2 times 3 equals 6, and 5 times 3 equals 15. And this is equivalent because 3 over 3, if we write that over here, 3 divided by 3 just equals 1. So we've actually just multiplied 2/5 by the equivalent of 1. And when we multiply the top and the bottom by the same number, we have not changed the value of the fraction. We have created a fraction that is equivalent. So now we can say 2/5 is equivalent to 6 over 15. Now, when we're doing our lesson, if we want to know if we've done it correctly, one of the techniques we have is to take our fraction and to cross multiply and see if it comes out equal. So let's rewrite this as 2/5 equals 6 over 15. Okay, so our fractions have already been created. This is just for our check. So we're going to cross multiply like this. 2 times 15 equals 30. And we're going to cross multiply like this. 5 times 6 is also equal to 30. 30 is equal to 30. That shows us that we have indeed created an equivalent fraction correctly because our cross multiplying has given us the same value. So it's important. A lot of students get confused. They think they need to cross multiply to create the fraction. That's not the case. The fraction must already be created. The equivalent fraction must already exist. And cross multiplying is one way to check it's correct. The next thing they are expected to know how to do in relation to equivalent fractions is if they are given something like 3/4 equals something over 16. So this time they can't just choose what number they multiply to create their equivalent fraction. Part of it has already been created for them. So their task is to figure out, well, what number has been multiplied? So they ask themselves 4 times what is 16? Or they can say 16 divided by 4 equals what number? From our times tables, we know 4 times 4 gives us 16. So if we find whatever the bottom number is multiplied by, all we need to do is multiply the top by the same number. So 3 times 4, and that is going to give us 12. So now we know that our equivalent fraction to 3/4 that we've created is 12 over 16. This is 16, sorry. This is not the only equivalent fraction because we could create another one just by multiplying by a different number. So let's do one more example. Let's do 1 over 5 equals over 30. Okay, so our 5's times table, 5 times what is 30? Well, 5 times 6 is 30. So that means I just need to multiply the top also by the same number of 6. 1 times 6 is 6. So our equivalent fraction is 6 over 30. So far, this is all we've done with respect to an equivalent fraction.